Hello, it all started off probably about 6 months ago. Slice Barcane had made a video challenging David Weiss on the accuracy of his Flat Earth Clock app. In it, Slice Barcane was challenging Dearth whether the sun would be to the right of this access road or to the left. And I had implemented this feature in my skywatching app just to predict using either the globe Earth or the flat Earth math what side it should be on. And one of the features that I added was the ability to overlay a graphic on top of the virtual sky. So for example, I can tilt the camera up or down, and I can go left and right like this. So my prediction was to show where the sun should be relative to this access road for any given time. This past spring and early summer, while I was doing other things, I was also working on a similar feature for my own purposes. And what I decided to do was to create a virtual camera. From time to time, you might have seen in some of my past videos, I will go to the Nepean Sailing Club. There's a marina where there's a whole bunch of boats over here. I was kind of curious to see what the sun rises and the sunsets would look like in this area. And the way I did it, I went there one day and I took a whole bunch of panoramic images like this, and I stitched them all together so that the left edge, when wrapped around, would join seamlessly to the right edge. And since the sky would be transparent, there was no need for me to extend this all the way up to straight up. I may revisit this image and extend it all the way down. I'll probably just fake the grass and just duplicate this much of the grass all the way down. But the point of this was to emulate what a camera on a pan and tilt mount would emulate if, for example, I wanted to create a virtual camera that would render a computer generated skyline on top of what the camera would see. So I was really more focused on just this much of it, and when I was done, I just removed this layer and I exported that to this PNG here. Given a known width of 9,934 pixels wide, I could then take 360 degrees and calculate how many pixels per degree of azimuth there are. And I had created this to be a rectilinear like image, and I used that same amount for the altitude as well. I used my theodolite app on my phone to get the direction of true north, which should be right about here in the middle. And so with that, if I pan the camera like this, the whole scene changes. And just like what Slice Barcane did, I can see where the sun should be at any given point. And so as of tonight, if I were to stand on the same hill that I was on when I took this panoramic shot, theoretically I should see the sun descend past this tree at the time of sunset. Keeping in mind that if the sun is just circling over our heads, this is where the sun should be, as opposed to over here. Unfortunately, it doesn't look like the weather is going to cooperate this week, but since we are approaching the autumn equinox, I thought that I would try a similar experiment to what Slice Barcane did. I'm going to use David Weiss's Flat Earth Clock app. I'm going to compare the expected sunset azimuth from his relative to what I generate in my own app, and the first sunset evening that appears to be somewhat cooperative, I'm going to go back there and I'm going to take a few images. I'll probably take a short video clip, and then I'm going to make another video to show my results. That's going to be it for now. Thank you for watching, and yada yada yada. See you in the next one. Bye.